What does the mean? Oh man, statistic stuff. We'll talk about it later. Cover this. We covered that. We covered. We didn't cover this one. Comparisons, 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 comparisons. Least common number. Remainder, and then. All right. Come on, man. Oh, it's in the other one. Gosh. And so I plane the equation. Okay, it's 3x minus 2. Because, part 8, number 5.
Three consecutive integers.
The least of the 3 integers. -29, -28. B is the answer. B is larger, okay. All right, number 6. Seven. Eight. 9. So we got that. It's just this one. We have this one. These two. This guy and then this guy. Down and out. So we'll do that last. Martha invited 4 friends. Jerry. 7. I see. 1, 2, 3, 4, 5, 6, 7. I see. Number. No, that's exercise 7. Mm-hmm. Seven, 8, 9, 10. I think 7, 8, 9, 10. 7, 8, 9, 10, 3, 4, and 5. 7, 8, 9, 10, 3, 4, 5, and 6. Number 9. Seven, 8, 9. 5, 4, 3. All right. Okay. So we'll cover this circle, and then we'll cover the rest of these guys. Maybe comparison, Venn diagram. This guy more. Hello? Can you hear me? I was having like audio problems earlier.
Hi.
Hey, how you doing?
Okay.
How's everything? How's the brutal studying?
I've been at it for 7 hours right now, as of right now.
Oh man, that's super. Yeah, hopefully you took breaks. Okay.
I just don't feel like I'm getting anywhere, you know? I feel like I'm putting all this work in and it's not clicking.
Yeah. No worries. Actually, I like some of the you sent me some data analysis ones. I can yeah, those ones, they're not that bad. A lot of it is like, I just call it statistics. We can cover that. Like, did you wanna like go over, I guess, just like, start off from where we left off last time?
Sure.
Okay. Did you look at that again? That problem? I think I sent that. What I'm gonna try to do is like send these two so that it's like easy to to refer back to.
Okay. I didn't look back at what we did, but I did read the thing that you sent, like converting word problems into math. And what I've been doing most of today is just trying to work through that math review in the book. And I did that. Well, I tried to do some more practice GRE problems and I couldn't. So that's what I sent you those too.
Okay. Yeah, we'll cover like the how to attack that. Let's do it like one by one first, so that like I think we did algebra, and then we'll do more of the set of the problems that you sent, and then kind of like we never covered like the comparison problems last time. I think that's very important. Yeah, because there's some things there that like they're very common that.
Which is is quantity A or quantity B greater, or are they equal, or you can't determine?
Yeah. Yep.
Yeah. I couldn't, I was looking at those today. I was like, I don't even know how to get started.
Okay. Yeah. There's a tip for doing those. That's pretty common. Like what I usually do. We'll get to it when like more, but in general, you can technically the very first thing is simplify, like A and B.
Right.
And then you can actually like the same way if it's like an equal sign or like inequality, because it is, right? You're comparing both of them.
Right.
you can like operate on both, like add one minus to the other. And then my goal is to make it so that you have like, if you can get one of them to be like a number and not a variable, it's easy to compare.
Okay.
So if you can get one, like A as like just a number and then B as like an X, it's easier to compare than like if there's two variables that you have to plug in on both sides.
Right. Okay.
Yeah. And then the other thing for that is, like, after you simplified it to the, you know, the simplest form, you should try to plug in like extreme values. You know how like there's always a prompt, like it gives you a prompt and then compare A and B, right?
Right.
So the prompt will tell you like what things to plug in, but then, you know, it's case specific, problem specific. But then you could always plug in like a range of numbers, which kind of like that's the part where like people are like, oh, what should I plug in? So
right.
Yeah, but you're actually that it's both good and bad. But like one thing I always say is try to plug in the extreme values. Like for example, if you're between 1 to 10, like you have the luxury 1 to 10, maybe put like case 1, plug in X as like 9. So that's like at the periphery, you know, of 10.
Right.
And then the other one as 1, not 1, but like 2, you know, like, and then that's like at the lowest end. So, and then compare the case 1 and case 2, and this is always the, you know, the underlying like, oh, so if this is the case, it's always that if case 1 and case 2 contradict, like if for case 1 you get like A is greater than B.
Like case 1 is where you're putting in 2 and case B is where you're putting in 9.
Yeah, like either one. It could be anything. Like I'm just saying, like this, case 1, case 2 are like arbitrary numbers you're plugging in. And then like if you get like a contradictory, like for case 1 you got like A is greater than B, and case 2 you got like B is greater than A. It doesn't satisfy, right? Like they're not the same thing.
Right. So you couldn't determine the relationship.
So it's always D. Yeah. If there's a contradiction, it's always D. But if you have case 1, case 2, case 3, I always just go with if I know like case 1 and case 2 give me both A is greater than B or whatever, B is greater than A, both of them, then I would like to do a case 3 just to confirm, like a middle.
Like maybe so like, put in a negative number or 0.
Exactly. Yeah. You have the luxury to like pick any number, but you got to be logical with the numbers you pick.
Okay.
Yeah, we'll go through a lot of those. I think that simplistic approach makes it really easy to remember.
Okay. All right. Yeah, this is what I need is just.
Yeah. Okay. So like, do you remember doing this on the vertex?
Yes.
Okay. So as I think we left off, we were talking about this quadratic form.
Yes.
So y equals x squared minus 4x and minus 12. And then we want to like create this problem is specifically asking for the vertex of this parabola. Whatever it is. And then in order to do that, in order to get this vertex, you need to get this vertex form. You need to transform your quadratic to this vertex form.
Okay.
Yeah. And then so how you do that is you have to complete this square. I think that's where we left off, completing the square. So we start off for a quadratic like this. I always leave off space here because you have to complete a square. So how you do that is, so you take this.
Wait, can you scroll it just so I can see the original quadratic formula that we had? Oh, because there's already a negative 12. Oh, I see. There's the negative 12. Okay.
Okay. Yeah, this negative 12 is the one that we have.
Okay.
And then now we have to complete the square on these x's. So this negative 4, this is how you do it. Let me know if something seems unclear, but this negative 4, in the coefficient in front of the x, you have to divide it by 2.
Okay.
And then you have to square it.
Divide it by 2 and then square it. So how do you know that you have to do that?
It's a rule. It's just a rule. Okay.
Okay. So the rule for finding the square.
Yeah.
is you take the coefficient of the x term.
Okay. Yep.
Divide by 2 and square it.
Exactly. Yeah. That's the way.
Okay.
So you do that.
Wait,
Yeah.
let me write this down here. So find the square. So take the coefficient of x term, divide by 2 and square. Okay.
Okay. So you got that one, and then so when you do that for our specific case, you're gonna get a 4, right?
So yes.
Okay. So after you do that, you have to add it. This is the tricky part, because then maybe I'll use another color so it's easy to see. So after you get this 4, you have to add it and minus it. What does that do though?
It cancels out.
So yeah, you're not supposed to change this equation. That's why.
Okay.
Because like then like it's not the same equation. You're not solving the same equation.
Right.
So, but then you could add +4 - 4 +0, and the reason why you're adding a 0, but essentially, because you want this +4 to complete the square of this thing in the parentheses, but then you have to balance it so that technically it's not there. It's the same equation. That's like the concept. It's super weird, but that's how you do it. Yeah.
I definitely do not understand it, but oh well.
It's just that rule thing, Okay, that part is just something you have to accept, and then this x squared minus 4x plus 4. This is it. This is pretty much all the hard like we've pretty much reached that point where you just have to simplify. So after you do that, you simplify that quadratic equation to like x minus 2 quantity squared. And then this part outside the parentheses, you simplify that as well, which is like minus 16.
Okay.
We're almost there, right? Like it's kind of looking like this guy.
Right.
The end goal is to make it look like this guy.
2 squared minus 16. I feel like I'm never going to be able to get this.
This part is like, it's just this minimal, like this right here. There's probably other concepts out there that we have to like talk about, but I was reviewing some of the other ones. They're kind of just logical steps, not less advanced math stuff,
Right.
Yeah. So like as long as we have for the bulk of it, it's just knowing the algebra. If you get that part, and then geometry, the line, creating a line, I think.
Yeah. If any problems ask me to find the vertex, I will not be able to do it. That's just a given.
I would say like like trying to see the pool of questions that are there. What I did before, what I've suggested is, if there's things that you don't want to answer,
right,
then know that you're not going to spend time on it, because it's just going to eat up your time, right? You're going to eat up your time. You don't like doing that. So skip that. Work, manage your time wisely with the ones that you know for a fact that you can get. But then also, like during that exam, maybe do like a scan, like 1, 2, 3. 3 is like the hardest, 2 medium, and 1 you got it. You can solve it in 2 seconds. Yeah. And then like the fourth one, category 4, just guess.
Right.
Yeah, that's a good like test taking strategy, is just categorizing the problems.
Okay.
And then because like the level 4 problems, like these ones, you have to work at it. Like there's just so much time for, if you leave it the last minute. I mean, it makes sense. You can oh yeah, the other thing is a POI, like was it process of elimination, or POE, whatever. We're gonna talk about that later with sometimes it works when like something logical, like if a problem tells you like A, B, and C, and then if you can eliminate the most illogical one, then even if you're not solving the problem directly, at least that you're like 50%, or maybe in your mind like 60, that you probably got the right answer.
Okay.
Okay, so yeah, like do you at least get the concept, kind of? with this one.
I think I'm just lost on this one. I'm a lost cause on this. It's not making any sense.
But yeah, in the end, yeah, that's it. Okay, let's try to move on.
Okay, I'm sorry.
No, it's all good.
Have it.
Let's go to something easier. I think we didn't solve these two. Do you remember doing these or looking at it? Ratio, and then this is the remainder one.
Let me see.
The remainder problem.
That was one of the GRE problems.
Yeah.
Like, let me pull it up here.
So I guess if you find this one, let me see which one is it. This I wrote down the question for this.
Yeah, if you find the number, that's exercise 13A.
I think it's just 13. I just put A here because there was a lot of 13s.
Let me look for 13.
I forgot what section.
The salary question? No.
This is the dog and cats.
Huh? Where was that question?
Okay, let me look back.
Oh wait, hold on. Maybe it was in the other. Hold on a second.
Okay. It says arithmetic.
No?
It says arithmetic exercises.
Oh, so that's in the math review. So I've got to go to arithmetic. There's so many areas. It's okay, I see it.
You see it? Okay, good. Did you get like for this one, how did you try doing this one?
I did, and it wasn't coming out with what they said the answer was. So I was doing it's hard to find where my work is now because I have so many papers around here, but so I put 20 at the bottom. So if there's 20 dogs, the ratio of dogs to cats at the kennel is 3-2. So you've got 3/2.
Exactly,
yeah. And then how many cats are at the kennel? So
yep.
You would put 20 over X, right? I mean, sorry, 20 X over 20. So 3/2 equals X over 20. No.
Let's see if that works. So that's what you said, right? 60
right.
And 2x. So you divide that, you're gonna get 30.
Wait, how did you?
You said 3/2, x over 20.
3/2, and then x over 20, right? Oh, and so you're cross multiplying, right?
Yeah, that's like. Is that how you did it?
Is that the right answer?
It's not the right answer.
So that's what I was getting, and it wasn't. Yeah.
Okay.
Obviously, that's not the right answer because there's only 20 dogs and cats.
Yeah, exactly. I know. Okay, let's try to these types of problems. When it tells you like 3 and 2, like whatever, sometimes when you have like let me think of it. When you're doing like a ratio. Like when you're doing a ratio, you could either do like this ratio can be the partial. Like for example, if there's like fruits, right? You have an apple and then you have an orange, and then the total would be like apple and orange. There's two ways you could do this, right? There's a ratio between like the different things, and then there's the ratio of like that thing over the total, right?
Right.
Yeah. So they gave you the thing with the other thing. They didn't give you the A over the total, and you need to do this on. You always want to do this. You don't want to compare using like a relative ratio. You don't want to do a relative ratio. You want the total ratio.
Okay.
So this relative ratio you have 3 and 2. This is always the thing to do if you're doing like a ratio problem. If they give you a relative ratio between the items, you wanna add them. You want to add these two things, so you get like the 3 ratio of dogs, and then the 2 in the cat to get the total number, which is like what, 5, right? 3 plus 2. So you have that 5 now, which is gonna become important. And then, so that 5, I would probably do that as like a ratio of pets.
Okay.
And then it could just be an like a variable 5. And then the next thing here is you have this other given number, which is 20, the total number of dogs and cats, right? And total number of pets.
Uh-huh.
So this is like real world item now. This one, the R was just the ratios. So that's how I usually think about it.
So, but you're adding the ratio of dogs and the ratio of cats to get 5. I guess I don't understand what 5 means.
Exactly, yeah. It's just that some of these it's just trying to find, this is a strategy for ratios. Because they always tell you to add the relative ratio to get an equivalent ratio.
Okay.
So this is what an equivalent ratio is of like the total, in a sense. Equivalent total, you know. So like every time they give you like a relative ratio, which is the 3 and the 2, or it could be 4 and a 1, whatever. It'll be 5, and then from that's the first step. The second step is use the real value, which is like 20 now, 20 the total number, and then plug it in this equation. This equation, you can use this for many things.
So n is n cats. N is the number of pets. You want to find, okay, so the number of cats equals the cats to the, I don't know.
Yeah. And then how I set up this equation is kind of arbitrary.
Okay.
If you look at this, I'll rewrite it again. So like, for example, what if it's asking about dogs, right? Instead of cats. If it's asking about dogs, it'll be like this. So that, you know, we got the mechanics of the equation. It's going to be like this. So our pets, and then n would be the real number, not the relative number. So if you're asking about the dogs, it will be this guy. And then if you're asking about the cats, just switch this. Just switch these. And then how you look at this equation so that it makes sense is the dogs are always on the top, and then different sides, and then this pets technically cancel each other. So the pet is a number here, and then
so those numbers are going to be the same, the ratio of pets and the ratio of the number of pets. Or is that our pets, is that 5?
That's the 5, the relative ratio.
Okay.
Yeah. If you remember, this equation is really simple. Like you have the real number of like items is a general, and then item 1, and then R as like item 1 again, divided by like R of total, and then N of total. But the key point here is never work with relative ratios, work with real ratios, which is like this equivalent
ratio. That 5
ratio.
that we got is a relative ratio, right?
That 5 that we got is like, it's like an equivalent ratio.
Yeah.
Like you add it, like, because like the relative ratio is like, what I did here is like you're comparing item by item instead of item to total.
Okay.
I know, it's like, well, it's like abstruse, you know, like why would you do this?
Yeah,
but that's like at the same time, like I kind of hate the GRE math because it's like a logical conundrum. You know, it's like, why are you asking me these things? It's like much harder than this. It's never straightforward, is what I'm saying.
Right. Yeah.
So it's a logical question every single time. Like it's never like a straightforward algebra question neither. Like even if you know like a lot of algebra, it's not just that question. Like you're gonna be like,
I think that's why I feel like I'm not getting anywhere, because I've studied a lot of like the basic math, but it's not helping me answer the questions.
Yep, yeah. And then there's another question there. Like they always like, you'll do most of that work. Not if you know the math, it's like 90% of the work. 10% is they're gonna twist you in like the question. It's like a slight twist where like, oh, by the way, you have the answer. Now apply it just 10% more.
But I mean, like when I was looking at the GRE questions today, I thought I would try some. Like I couldn't even figure out like how to get started. I couldn't even attempt it.
Okay, let's yeah, but then it's just like mainly getting the mechanics of the how to attack it. Like for this problem, the way I explained, does it make sense?
No, but that's okay. I mean, I can see that what you're going to do is take 2/5 and multiply it by 20.
Yeah, that part is the easiest part, but like, why did I do this?
Yeah, that's what I don't get.
Yeah, this part, like I said, like it's just one of those strategies where once you see, because like when you read this question, you see 3 to 2. It's not total ratio, right? It's not. It's like I think it's like dogs to cats.
Right.
It's dogs to cats. It's a relative ratio. So every time you see a relative ratio, but they want you to compare the total, you have to add them. You have to add them.
Okay.
It's just that mechanics. Like, okay, that's how you approach it. You can't work with 3 and 2. You have to work with the total.
So you'd have to with okay.
Yeah.
Great.
I think it's just that. I think I've seen this problem get like switched many times, but that's what I remember. You always have to add the ratios.
Okay.
Before you work with the problem.
Okay.
Yeah. All right. So that's equivalent ratio problem, and then this one's even harder. The next one.
When the positive integer n is divided by, yeah.
Yeah, this one's like one of those things like it's not like I don't know if you've done there's algebra regular, right, and there's abstract algebra.
Oh God.
Yeah, like it's like I would say like abstract algebra, which it's not like part of the regular curriculum. And then like if you're taking something like that, it's kind of like that. It's like the world where you work with variables, but then you have to like think about them in like what else can they be? Like a remainder. You think a remainder is just the remainder of a problem, right? Like when you're dividing something. But then you have to think like, what else can a remainder be? It can be this, and then in the next remainder. And this is what this problem is pretty much doing. Because let me try to, I guess what part of this do you understand the problem? Like,
what do I understand?
Yeah, what part of it do you understand? Yeah, first.
No, I mean, I just read it and was like, I have no idea how to attack it at all. Like,
okay.
Even figure out the first step in doing anything.
Okay, so what I usually do, and you've seen this a lot, is I write down the givens, right? So that I can like kind of frame my mind of how to attack it. So we have D, which is what is my D here? Okay, so we have the remainder. And then D is what you're dividing by. Yeah, there you go. D is what you're dividing by. And R is the remainder. And then this I right here is just grouping them. So my first group is D1 3 R1 2. Second group is D2 5 R2 1. And that's just from that's just from these guys, right? This is just what yeah.
And when
it gives you two things.
By 5, the remainder is 1. Okay.
Yeah. So I would group it that way. Every time it gives you like two groups, you have to write those down and see like what you can. There must be an equation that you have to apply. So now I want to know what it's asking. So what is this asking? It's asking me some weird question. It says least possible value of n.
Right.
Least possible value of n. That's not a very common question at all. What is the least possible value of n? So like if we didn't talk about this, you probably wouldn't know how to attack this one.
Right.
Like I haven't like seen this in a regular curriculum, but the first thing I would do is least common number assumptions. You would do like this number because it's asking you the least possible value of n, which is this number right here, is just taking the remainder for each group. So for each group, because you're going to compare them, is you take the remainder for each group and then you add what you're dividing by, and then 2 of that what you're dividing by. This is just something that every time you see this is probably a challenging question. Is you just do this because it's one of those abstract algebra stuff where if you have a remainder of this guy, you can add
here's the thing. This is already not making sense to me.
Yeah, I know. Like,
I'm ever gonna get. So maybe we should just not even waste time on it.
Okay.
I'm never ever.
This one's a real. Yeah, I was wondering about. Okay, if you were to get this, at least you have my notes on it.
Yeah.
Okay. Okay. Let's do the ones that are like more practical.
Right.
Yeah. So these comparison ones. So try to find this question. Do you remember doing this one?
Let me look for it.
I think this is section 5, QR.
Yeah, so, and that was number 5. So is this the one that's the least of the 3 integers, or negative 28? No. Which one?
That one's the other one, the other day. That one was today. The other day you sent this one.
Yeah, oh, this is from the other day. Okay.
Yeah.
Gosh. Let me look.
I think it's section 5.
So no. I have no idea where this is.
Let me see. I think it's like 355. I see a page number.
Oh, okay. That's helpful.
Yeah, and honestly, like it's like only what I can see from the picture.
Okay, I see. Okay, got it.
Okay. But do you remember doing it though?
Do I remember working on it?
Yeah. Do you or at least the approach?
I think all I tried to do was plug numbers in.
Okay. Is that let me ask? Is that the approach you always do with like the A's and B grouping comparisons?
I mean, I think what I would normally do is try to simplify it. So like 1 minus y is going to be something to y minus x. So I would maybe I would add y to both sides. So 1 is going to be something to 2y minus x.
Yep, yeah. That's what I would do, yeah.
So I get that far. I'm not even looking at your work yet. I'm just going to see.
Okay.
So x is greater than 0 and y is, wait. Okay, so x and y are between 0 and 1.
Yeah. This one, it's not that bad because they give you like this x, this range, right? This equality.
Uh-huh.
And then like pretty much like you could just like plug in a lot of things and then eventually so like what you did first, that definitely do that, like simplify it. And I think the reasoning for that is so that you're not comparing, you're not working with like both sides.
Okay, so I got that far at least.
Yeah, that's the best strategy. Always simplify it so that one of the A or B is like a constant. It's a constant value. That's the very first step.
Okay.
And then now, since you did that, B here for this case is the one that's variable.
Okay.
So you have 2y minus x. And then my second step, this is very important because depending on the values that you pick, you can't just base it off one answer, right? Like for one case, you could be greater, other case, you could be, whatever, equal.
Right.
So trial and error is always the best bet, but then a logical way of doing it is like the best way, better way.
Okay.
Would be, and how you do that is like you do like test the extreme values.
Okay.
So in our case, what are the extreme values? So you're given 0 to 1, right?
Right. So 0.9. And then, but so why wouldn't the extreme value of x be 0.1?
You could, but then that's the other one. Like you wanna do extreme right, extreme left.
Okay. Okay.
Yeah, extreme right, extreme left, like at the periphery of like the range.
Okay. So you put that in there and it equals 1 for those values.
So this is C. Like usually like they do it this way.
Right. Right. So that would be equal. But if you put in the extreme low values.
Yep. What do you get?
So you're getting it's contradictory. So it would be D.
Yep. Yeah. CBD cannot be determined.
Okay. So
every time you get like a different answer, it's contradictory. And it's always going to be D. This is like a simple one.
Yeah.
Like, but this is a common one though. Like they do this a lot because they give you like an equation. So every time you see this, you're probably going to be happy because like, oh, it's easy. There's probably a level 2 or 1.
Okay.
So level 2 or 1.
I'm not even getting those right, so I'm in trouble.
Okay, let's do another one. This is the next one.
Okay.
The more of these you do, this is actually easier than the algebra one though, right? This is algebra still, but
so let me
like
see
word
here.
problem.
Let me just try, before looking at your work, let me see how far I can get here. So I've got P plus S is something to PS. Oh, P is the probability that E will occur, and S is the probability that E will not occur. So if you're adding two probabilities, they can't be more than one.
Yep. Yeah.
So I don't know. Are you able to determine that?
You can. So let me. So okay. Let me explain like step by step then. Like,
Okay.
this one, at the back of your mind, you're always, for these comparison ones, you always apply two-stepper, right? Simplify, extreme value. Simplify, plug in extreme value. So that's always there. That strategy is always there. But then now the math,
extreme value. Okay.
and then now the math aspect comes in.
Right.
So then for this one, keywords are like, I guess it says here probability, and then P is probability, and then what does it say? S is not occur, right? S is the one. S is the one that doesn't occur. Like E doesn't occur.
Wait. So P is the probability that it will occur, and S is that it will not. Right.
Yeah, and then probability of anything is always one, right? The maximum probability is from the. Let me rephrase that actually. Probability can be 0 to 1.
Okay.
Right. Maximum probability is 1, but it doesn't have, like, the minimum is 0.
Okay, so S is 1 minus E. Okay, all right.
So this is what you have to apply, yeah, because this is telling you it's not E, right? The probability. Right. So it's 1 minus E. That's what it's telling you, but it's telling you that in words, but you have to apply that.
Okay.
Okay, so with that, now you have P and S plus S equals A, and then P times S equals B, right?
So you put both of these in terms of E.
Exactly, yeah. So
E plus 1 minus E is something to E times 1 minus E. So 1 is something to E minus E squared. Okay. And that's as far as you can take it down, and then you do the extreme values?
Yep, yeah. After you do that, then it's gonna make more sense. And this is the one where, like, you gotta test, like, maybe 3. The reason why I always do 3 is, like, the first one, I did, like, E. What I did here is I plugged in values for E. So it has to be 0 to 1.
Okay.
So E here, which is like 1. And when I plug in 1 for case 1, I got A, which is like greater than, A is greater than B. And then when E is 0, the lower end, I still get A. Okay. Oops, still got A. And then when I plugged in, just to check if there's no fluke, I plugged in a median value, 0.5. Okay. And I still got A. Okay. So that must mean it's A. Okay. All right. That makes sense. And that's how I would conclude it. Okay. Yeah. That right there is just that's actually a good one. I like doing those ones. Okay. That I'm having a lot of trouble with those, so that's good. Yeah. Let's try another one. It's but then, like, the framework makes sense though, right? Yeah, that's helpful, that strategy. So should we go to the next one? Okay. Tell me what you would do with this one. This is kind of, it's a little hard because it's a set. It's a set. So there's a lot of things that can happen. Right. I think that's why I just have no idea. Yeah. So tell me what you know first, I guess. Well, the givens. Well, it's, it gives you that 2 is less than or equal to, so n is greater than or equal to 2 and less than or equal to 5. So the absolute value of the greatest integer in x, so that would be the greatest integer that would satisfy that would be 5, right? Kind of, yeah. Let me just check. And
And
but then what about the absolute value? Yeah.
So the absolute value is 5, right? Because it could be -5 or 5, right?
Yep. And then so what's
the absolute value means it's positive, right?
Yeah. Yep.
So it's 5.
For which one? 5 for what? A or B?
So quantity A is 5.
Okay.
Right?
And what about
because
B?
it's the greatest integer that would satisfy X, right?
Yeah, that's correct for A. What about for B?
Okay. And then so B would be the absolute value of the least integer, and X would be 2.
That it's right, but then what about the negative? What about the negative?
But the absolute value means it would be positive, right?
That's the range after you apply it. Like the range. Let me not use range.
Oh, I see. So okay.
Things that you apply to n still can
the
be negative.
integer
Yeah.
could be -2, but the absolute value is +2.
Yep. There you go. Yeah.
But
Yeah.
still, that doesn't change the fact that A is greater.
Yeah. It can't be for this one. It can't be great. Here, let's step back. So A was 5, right?
Yes.
Okay. Now the B is the harder part here to say. So B is supposedly the least integer or minimum
Right.
integer.
Okay.
So I guess looking at the set, we know obviously from the equation there's going to be 2 and 5 in the set, right? But what about like the negative numbers?
Oh, so it's -5.
Yeah, the negative numbers. Yeah, is the least one is -5.
But still, that doesn't change the answer that A is greater, right?
But then when you do the absolute value, it's going to be 5 for both, right?
Oh, so they're equal.
Yeah. Yep. Yeah. So that's the ending of that one.
The end of the story is they are equal. Okay. Okay. All right.
It's one of those. It's tricky because it's like, do you really know the absolute value?
Right.
That's what the GRE tells you. It unravels like your basic fundamentals.
Right.
Do you really know it? Because then it's not the advanced stuff. They'll never ask you advanced stuff. They'll ask you like weird questions.
All right. Well, what about the next one here?
Okay. All right. So let's look at this one. I think this is number 8. This one isn't that bad. What do you think you're gonna do?
Well, I thought I got close on this one, but then I just wasn't getting the right answer. I thought I got close. So okay. So if I've got hold on a second here. So if I've got x to the m over x to the third is something to x m over 3, right? Which is that the same as the -3rd power?
Which one? The xm over x to the 3?
Or quantity B, is that x to the -3 power? No, it's not. Never mind. Sorry. Okay, so I'm going to multiply each side by x to the 3rd, right?
X to the 3rd. Let me see if you can do that. You're going to multiply both sides by x to the 3rd. You could, I guess, yeah, to take out the fraction, right?
Right. Or is that not the right thing to do?
Let's look at that. There's many things you can do.
Okay.
So let's try to do that one. xm3, and you multiplied both of them by x to the 3rd.
Right.
And then let's look at the b now. So m over 3. Then you're gonna add 3 to the exponent.
Right.
And x, it could work, and then you just start plugging, because you're gonna end up plugging in extreme values again. Like
that doesn't seem very.
But then it's a logical step. Do you want to go with what you did?
No, I'd rather, if you have a better idea, I'd rather see that.
Okay. All right. Time to look at what I did here.
Okay.
So like the first thing. No, like what you did is right. That's the simplification. So you could simplify it that way. But I guess let me just cover what I would do for like the range first.
Okay.
So this gives you like x has to be greater than 0, right? And then m has to be greater than 0.
Uh-huh.
And then x and m. this is just me like looking at like what can I plug in, you know, thinking ahead, like there's things I can plug in, right? So for x, this is giving me, it's a multiple of 3, right?
Right.
Like m is a multiple of 3, but x can be like any positive number.
Right.
Yeah. So if it can be anything, why don't you just pick like very easy numbers? So I did like 1 to 4 for my low end, and then high end 7 to 10.
Okay.
And then I kind of match that with the same index, like 3 to 12 for m, and then 21 to 30 for my high end.
Okay.
For m, yeah. So that's just me setting that up, and then now let me simplify it. So like this is how I usually would simplify this, because I don't like working with exponents.
Right.
So the one thing to get rid of them is to apply this natural log, or like a log. Yeah. I'm
not familiar with that at all.
Okay, but let's see. If we did that, like if we did that, you take out the exponent. That's why. And like, look how easy it is. Now you're pretty much just doing this.
Okay.
Yeah, like the other way you multiply it by x.
So you can just take that x out and just compare the exponents?
Yeah, you know why?
Why?
Because it's the same. It's the same value.
Okay.
When you have same values, you could assume you can cancel them.
Okay.
Yeah. So in my mind, like after you do that, it's just in a way like, because you could in our case here, right? Like once you apply the ln, if you knew the rules of ln, you can cancel it out.
Okay, so it doesn't matter what x is.
It doesn't matter what x is. Now you're comparing m, which is what you like to do.
Right.
It's less work, so that's what I end up doing. Maybe, you know, like the rules of ln is if you take a look at it, it's just like doing a multiplication in a way.
Okay.
Because like after you do this, that exponent, the rules of it is after you apply the ln, that any exponent comes and gets multiplied to the ln. That's the rule. So once you apply the yeah.
Wait, say that again.
So once you apply here, let me do the basic, like a basic one over here on the side.
Okay.
So, you know, when you have like x to squared, let's do something basic.
Uh-huh.
And then let me apply ln to this guy, right?
Uh-huh.
So any exponent, and then you apply ln to it, any exponent to this goes to the front. It becomes like a coefficient, and it just becomes this guy. This is the same and equal.
Okay.
So in this case, that's what we have. We have a bunch of exponents, a division, a subtraction one. So now let's make that harder. Like, what if you had like x2 minus a, and you applied ln to it, right?
So it would be, so yeah.
Yeah, any exponent comes out and just gets multiplied.
Okay, any exponent comes out and gets multiplied.
Yeah.
And that's why you were able to cancel out the x's, because you have one on each side.
As a multiplication term. Yeah. As a multiplication term, yes.
Okay. So it's not like ln lets you cancel out that number. We're only able to do it here because it's on each side.
You got it. Yeah.
Okay.
But you have to remember ln somehow.
Right. Okay.
Yeah, yeah, that one, I mean, remembering that is helpful. Like, you're gonna see something like this.
Right.
Like, the other rule of ln is let me see if we need to even apply that. Nah, let's not apply that. I think there was a problem later on that we are gonna apply that. So
okay.
I'm not gonna cover it until we get to that point.
Okay.
So for this one, yeah, just remember that that you can do that. That's like a rule for ln. Anyways, so after you do that, you have these m-3 and m/3, right?
Uh-huh.
And then, that's easily comparable. You do the extreme value.
Right.
And then for the first case where you plug in m equals 30, you have a, and m equals the lower end, you have b.
Okay.
So it's contradicting. Yep, so it's d.
Okay.
Yeah, this one, yeah, it's like that. It's just maybe do more of the ln. If you know your ln, this one shouldn't be a problem.
Okay.
It's like these comparison ones, like, and when it shows you something like two set, I've always thought like when you have a and b, and then it's like an equation, like algebraic equation. It's relatively easy because you can just manipulate and plug in, rather than like this really weird like probability. It's another step.
Okay.
Okay, I think for that was like did we do 9?
We didn't do 9.
Okay, let me take a look at that one. Or did I even do it?
So
We can look at it. Were you having troubles with that one?
oh, I have trouble with all of them, so it doesn't matter.
Okay. We'll look at that one. So let's see. So what is A and what is B?
So the probability of the event that the value of y is greater than 220. So normally distributed, the mean of 200.
At least one of them is a constant. Okay.
Huh?
At least one of them is a constant.
Yeah.
So that's at least a good thing. So a random variable.
Yeah, I just didn't even really know how to even start with that.
Okay, so for this, let's see. So this one is 1/6. So do you remember like statistics? Yeah, that like the bell curve.
Yeah. And that's what it means by saying it's normally distributed, right?
Yeah.
And I know, so
the
the mean is going to be right there in the middle. It's 200.
and then this is asking like this is 150. So the probability of the event that the value of y is greater than 220. This is A, right?
Right.
That's what it's asking. The probability of the event that y is greater than 220, and then you have. Let me just see this one. So it says here that the mean, which is this one right here, the mean in the middle, and then you have bell-shaped curve. And then standard deviation is like 10, right?
Yeah.
So 210, 220, that's 2 standard. Yeah, and then the other one is like 190, something like that, 180.
So the probability that y is going to be greater than 220 is pretty low, but I don't know how to calculate that.
Let me just see. Roundabout is normally distributed with a mean. Yeah, it doesn't give you a basis. 95%. Let me see. There's supposed to be a basis, like a percentage.
Right.
Does your book tell you like what to assume? There's some. I remember like you can assume a few percentage when you do this. So
you can what?
You can assume a set of percentages, like 34 or 13, something like that.
So should I see if the answer? Is that what you mean?
Yeah. Try. Is it like? Let me see. Is B greater?
Let's see here. Let me find section 5.
It looks like B would be greater.
Well, I'm looking for. Nine. It's hard to go back and forth here. Okay, here we go. It says choice B, so B is greater.
Okay, but then like setting up your probability questions, does it like before this? Does it ever tell you like how to attack?
Yeah, so it says, thus the
Okay.
value of 210 is 1 standard deviation above the mean, and the value of 220 is 2 standard deviations above the mean. To compare quantity A with quantity B, it's
Yeah, I
not
remember this one.
necessary to exactly determine the probability of the event. Remember that in any normal distribution, all of the data values, or about 95% of them, fall within 2 standard deviations of the mean. This means that less than 5% of the values in this distribution will be greater than 220s. Thus, the probability of the event that y is greater than 220 must be less than 5%, or 1 out of 20. So it's 1 out of 20.
I think I got it.
Okay.
I think I got it. Okay. So I think this is usually like the percentage, you know, like back in your mind, do you remember like remembering or like learning like there's percentages that's associated with these. It's usually like 34.1.
Right. Like 50% is 1 standard deviation on either side, right? Oh, no. Okay.
It's 34. I think it's about 34.
Okay.
And then once you get to like once you get to 2, it's like it goes down to like 13.59 or 6.
Okay.
These are the percentages that, because it never changes, it doesn't change. Even if like whatever scenario you have, it's a normal distribution, bell curve.
Okay,
and that's
so the 1 standard deviation on either side of the mean is going to be like about 2/3.
Yeah, but like if you keep these ones in mind, so maybe up to only the third deviation, like, you know, this is like 2, right? This is the third one, right? This is the second one. This is the first.
Yeah.
And this is the second. This is this guy. And yeah, so this one is asking you, like, what was it? P is greater than 220. Like the Y that is greater than 220. So
Right.
and then you put values in these ones. So this is 210, and then these are 220 right here.
Uh-huh.
And then like,
So the probability.
It's this guy. This
Yeah.
is the one that you want, not the left hand side. So I'm thinking, is it 13? So that's 210, 220, 210, okay. 210, 220. Okay. Not 13 here. It's supposed to be, let me just take out this part. 1, which is that guy, and then 2. It's everything here. If you drew this, let me just share this this part with my other screen. It makes more sense. All right, tell me when you see this.
Okay. Yeah.
You see this?
Uh-huh.
Okay, so you know how you have 13.13, 34.13, 13.59, 2.14?
Right.
So, and then when you put in the 200 and then 210 and 220 here, 220 lands in the second part right here where it says 2%.
Uh-huh.
So it says you want a probability where Y is greater than 220. So it's everything on this right end. So it's going to be 2.14. That's your probability.
Okay.
And then, so what is that compared to 1.6? Which one's greater?
Well, so let me find out. Hold on. Let me get my calculator. So 1 divided by 6 is like 17%.
Yep.
So quantity B would be greater.
Yeah. So that's how you attack. It's actually not that bad if you know the percentages.
Right.
This is no percentage I was like referring to, but I think in my my prep book it showed me that you could actually assume those. But maybe for to build like a strategy, just remember the percentages.
Right. Okay. Yeah, that's good to know.
Whoa, what happened? Oh, come on. Okay, let's go move on to the other one.
Okay.
All right. Okay, which one did you want to work on?
Oh God, I don't know anymore.
So like I'm looking at the one I have. There's this guy. There's this guy. If you remember this one.
12B. God. Was that like a practice question? Do you have a page number?
Let me look at it. My computer's like acting up, but let me look for my other one. Like that page. Okay, there you go. This is like one of the questions you sent me today.
Okay. So that's probably one of the, let me look. 12. Okay, I see it. Yeah.
Okay, so you see the question, but and then let me see if this is not a comparison one. This is a word problem, right?
Yes.
Okay. All right, so let's just attack it. Like, so this one is giving you these two things, right? These two equations. I kind of just skip like the givens and finds just so that I can give like a solution.
But how did you get that they equal each other?
Because what does the question? It's something in the question that I read.
So the expressions in the table above give the distance from Centerville to each of two trains.
Oh, here you go. I found it. Yeah. So the expression in the table above give distance from from Centerville to each of the two trains after at what time will the trains be equidistant? There you go. Equidistant. And that's why it's equal, because that's the distance.
But we're trying to find at what time they'll be equidistant.
Yeah, but then once it says equidistant, and these two equations are the distances, right? T is the time. T is the time. Yeah, that's how you find it. T is the time. But then because they're equidistant, the word there, you can make them equal.
Okay.
Okay. And then, so once you find, there's like no other pathway. What else would you do?
That's why I couldn't get anywhere.
Yeah. So, but then like seeing that you could apply it, then you can get a T, right? Like that would make sense then, right?
Right. So 10T equals 35. And then why are you dividing by 10? Oh, to get rid of the 10T. Okay. So
Yeah.
T equals 3.5. So at what time? So it would be 3:30.
Yeah, this one's an easy one, but what if it doesn't give it to you in like 12 p.m., you know? Like, I mean, obviously just telling time. This is what you have to do with this one. It's just that 10%, like I said. Like, you know how to get T. Let's just solve for T from this equation. But now it's asking you at what time. So
yeah, so you just have to translate 3.5 to time, which is 3:30.
yeah. And then that's what's pretty much what it's asking you. It's really is just like probably equating these two is what you had to do. But it's not that bad.
Okay.
For this one, like it's one of those things when like you want to attack something and then you're giving two equations, just force them to be equal, even if you didn't know equidistant meant that they're the same.
Right.
It's like one of those things, like you have your arsenal, you know the procedures that you have to apply, but then that's how I would attack a question. I wouldn't read through the question where like, oh man, what do you have to minus these, or what do you have to do, you know?
Right.
Try like force yourself, like, okay, I know there's two equations. This must mean I have to do something to them. And especially like both of them have T, you know? Both of them have T. So they have to equal each other. Both of them have T. But then I had to confirm it if you do have to, and the word equidistant is there, so.
Okay. Well, the one after that I really couldn't get either. The quadrilateral I just, yeah.
Yeah, this one is definitely a weird one.
Yeah.
So how like a lot of these ones I probably would classify this like as a 3, like one where you're like, okay, after the second sentence, like, okay, let's skip this, let's go move on. But
Okay.
if you do find this, that's the thing, like the more problems you do, right, and you remember doing them, the more chances you'll get a higher score, right?
Right.
Yeah. So when you see this again, yeah, you know how to attack it now. So, but like,
Okay.
okay, let's do this. So it's telling you here. This is really like I was trying to find like an easy way of explaining this one, but I tried my best here. It says 1 and then 2. So the first step would be you have this old like quartile, division of these two things. So
Right.
this is the what you need to look for here is I think there's a distractor. Yeah, the distractor is this 43,700. You don't need that one.
Okay.
And then so you have this 80 people, right?
Uh-huh.
And then it says here that for the old, I classify this as the old grouping.
Okay.
And then you add 8 for the new grouping.
Okay.
So for the old, which is number 1, let's take a look at the groupings, because then it says here there's 4 quartiles, right? That means a quartile.
Uh-huh.
So you divide the first grouping of people by 4, you get 20, right?
Uh-huh.
And then so first quartile is 20 people, or 40, and it's 1 to 20. It's all of them are 20 people, but then the first quartile is 1 to 20, and then the second quartile is 21 to 40.
Meaning the people.
Yeah, the position of the people. Yeah, and then the third quartile is 41 to 60, and then the 80 of the fourth quartile is 61 to 80.
Okay.
So it's kind of like what is the framework of this problem? And then I'm seeing it as like what group, right? What quartile, that's the group.
Uh-huh.
And then like what position of the salary are you in?
So let me
right?
see what it says here. So what would Mark's salary be with respect to the quartiles of the 88 salaries?
Yep, it's like a position of the salary, pretty much.
Okay, so it's basically, okay.
There's a lot of things like this can be asked in like many different ways, but it's the answers to the question. It just says like the position of the salary, and then the grouping of the quartile.
Right.
Like first or second, yeah.
The second highest in the first quartile.
Yeah. So this is how I would think about it. So you have first quartile, second, third, and fourth.
Uh-huh.
And then within each quartile, you have positions, right? 1 to 20. These are the positions, 21 to 40.
Gotcha. Okay, so he's at position 78? No, 79.
And let me see. And then the first one here, if the company were to hire 8 new, and let me see. Second highest, if the company were to hire 8 new, what would actually be respected to the quartiles of 88? But at 80, each of them is second highest in the first.
But it wouldn't change his position at all, right? Because all the salaries that are added are lower.
Yeah, but then so you have the second highest in the first, right? So he would be 19, I think. Second highest. 20th would be highest.
Oh, so the first quartile is the highest salaries.
It says here 2 things. Like it says that he's the second highest, right?
Uh-huh.
In the first, in the old grouping. Second highest, so 19. He's group 9. He's on position 19.
Oh, so he's got a low salary. I was reading that as he was like the second highest in the company.
Oh no! Like, I think it's the grouping, the second highest within the first.
The fourth quartile is the people with the highest salaries.
First quartile,
and he's in the first. Okay.
He's in the first, yeah.
So he's number 19 in that first one.
Yeah, and then now you have to add let me see what it says here. If they were to hire 8 new that are less than the lowest of the 80, what would? So let me think. So now he's 20. Or 21 rather, and then you would have to add.
Wait, why did you get 21?
Let me see, because he added 8 people, right? You have to think about it that way.
He added 8 people.
Yeah, so he was 19 in the beginning. Because the second highest of the first. And then
all
you have
the people added were at the beginning.
This is 8. Let me see this one. 8 are less than. If the company were to hire 8 new is the are less than the lowest. What would less than the lowest of the 80 salaries? Less than the lowest. So that part right there is like.
Meaning they're going to be salaries 1 through 8, right?
Yeah. Oh, hold up. So when you add that 8 in here, you have to add 8 in 19. That's what you do. So you get 27.
So he'll be at 27. Okay.
Yeah, that makes sense now. I was wondering, like, I was doing so many problems earlier. Yeah, like even I'm getting confused.
Oh my God.
So okay, there you go, 27. Because of the 8 new people.
Right. So his position is now 27.
So this 27 is this guy, 27.
Right.
You still see my screen?
Yes.
Okay, you still see it because I was like switching over different screens. Okay, so 27 here is his new position, but then like what is that relative to his quartile? So now you have to look at this new grouping. It's not 20 anymore, it's 22, right?
Right.
So that part makes sense. So now you do the new grouping, 1 to 22,
and instead of being in the first quartile, now he's in the second, right? Hello? Can you still hear me?
It's telling you like the grouping, and it tells you the position.
Right. So now we know that he is the
and
highest in the second quartile, right?
Yeah. So you had 3 choices there for a second quartile. Is it the second lowest? Is it the third lowest or the 5th lowest?
Let's see. So he's the 4th lowest, right?
So it starts with 23.
Right, and he's 27. So the difference is 4, right?
Yeah, but adding 23 with 23 though, not without it.
23, 24, 25, 26. So the 5th?
Yeah.
5th lowest salary in the second quartile. Okay.
And that's what I got. Yeah. You have to like draw a picture with this. I mean, this is kind of like me drawing that. You don't have to draw like stickman, but you just kind of like think about the position.
I tried to draw a kind of picture like that, but it didn't get me anywhere.
Yeah. I think this one, yeah, like if you do see this again, I'm pretty sure you'll get it.
Okay.
Okay.
I am not confident at all about my ability to do this.
What I'm gonna do is I'll set. Did you still want to continue?
I'm a little fried. Let's maybe.
Yeah. Okay.
Well, I don't know. I guess we could keep going. I don't know. Whatever you think.
Did you want to like do like there's? I think there was one. Let me see how many more are there. Because like what I was envisioning is if we finish the ones I have here like shown, I'm gonna, because I haven't gotten to the ones I haven't done with like a solution set are like the data analysis that you sent me. And half of the comparison. There's like another set of comparison. But if I send those to you, like I'll have time to like really like, write down like the assumptions and maybe and then if I explain this part, then for those you can just take care of the other ones that we didn't cover in terms of like, oh by the way, I don't know this part, and then maybe we'll talk about that like later this week. You have a lot of time. Like honestly, like you have a whole week, right?
Yeah, but I feel like I'm just not getting anywhere. I'm putting in all the time, but I'm still not getting any of the questions. Yeah,
it's just like you did like a lot of problems today. Some of those you saw like similar things, right? Like there's like, it's not like every problem is always different.
Right.
So in that sense, that's how I always attack it. Like try to group them. Like, some of them are similar. Maybe and then, half of them are probably like in another subgroup. And then for the one, and then, the procedures that we're talking about, like what I'm trying to give you here is like the, kind of like layers of like strategy where you have the main procedure that you can always apply.
Right.
And then like for each specific case, for each problem, there's like the math things that can vary. But then like really it's just checking off that list, like which strategy can I apply, and then try to force that strategy in that question. And then like if none of them are working, you're down to your last note. Then just skip it. Like, okay. But like at the same time, you can't be like taking your time though, right? That's why you have to do a lot of problems.
Right.
So that like it kicks in, like, okay, this is and that, and then the more you do it, the more natural it gets, and then you can spend most of your time on level 4 problems.
Right. Yeah.
That's how I usually attack this kind of stuff.
Okay.
Okay, let's see. Whoa, what is going on? Can you still see my screen?
Yes.
Okay. Why is that? Oh, it's not good. Okay. Let me recast this time. Okay, this one works. Okay, now it works. Okay, all right then. So, do you remember this problem?
Yes.
Okay, so like what was this one asking again?
The value of m, which is the radius.
Okay, and then so how I would set it up is you have like 3 different coordinates.
Right, and I did this. I kind of like tried to draw it like that.
Okay, and what was your m that you got? You got to an m?
I couldn't figure out how to get it.
Okay. So did you draw a picture?
Yes.
Okay, when you draw a picture and then it's kind of like this, and then you have to like apply, like once you do something geometrical, you have to apply like these basic things, and this in green is what I mean is like after you're given a few points, right? You're given 3 points. You wanna find the distance between them. And this is the first one, right? So that's 12, which is like from the first point to the second point.
Right? The distance between the center.
Yeah, and then the second point.
But we're not given that, right? How did you get that?
The second point is given to you. Like it tells you -6 and 5 lies inside the circle, right?
But I just see where, because if you're at this, oh, I see. I see, because the distance between -7 and 5 is 12. Okay.
Yeah. Yep. It's 12. Yes. I mean, yeah, you could pretty much just read it off. If you drew a picture, you could just pretty much read it off.
Okay. And then so the distance between the center and the other is -6 to 8, right? Which is 14. Okay.
Okay. So that's pretty much like the first step, figuring out those distances with this type of problem.
Okay.
Yeah. And then so because like if you don't draw a picture, you don't really know like, oh, like why does it matter if it's inside or outside, right?
Right.
So I specifically did that. Like this is inside and this is outside. And then this is the center. And then so what is m? It's telling you m is the radius of the circle. And it tells you something else about m, right?
It just says it's an integer.
Yep. And so that's very important. So this is that green right here. So since it's an integer, so you're given, like, you found out that the one inside the circle is 12, right? The distance. And the one outside the circle is 14, right?
Oh, so it must be 13.
Good job, yeah. Yeah, that's how you do it. That's how I would think about it. Like, if you drew the picture, you got the values, you're like, oh, now it makes sense.
Okay.
There's no other choice.
Okay.
Does it make sense?
Yeah. That is the answer.
Yeah.
Yeah.
But like, what about the thought process though? Like, why did we do that? You know,
No,
like,
that definitely makes sense, because
this one is
the
like
radius is going to be the distance of the line from the center to the edge of the circle. And so if we know it's an integer, it has to be a whole number. One's 12, one's 14. It has to be in between.
Exactly, yeah. That's why, like, the picture doesn't really matter. Like, if you know the distances, like 12, which is outside, inside, and then 14 outside, the in between would be the inside, which lies on the, I mean, not inside, but lies on the circle.
Right.
Yeah.
Okay.
That's how you do
that makes sense.
Okay, let's look at this other one.
Right.
Yeah, like, how did you look at this one? Let me see. This one is a hard one, honestly.
Yeah, I mean, I got that it had to be an even integer, but I also said it could that it's a negative number, and that was
It is.
not true.
So let's hash that out. You're not like incorrect with the negative one, but the way I would attack these problems, like, I have like method 1 right here and method 2. Like, M1 is method 1 and M2 is method 2.
Okay.
So, like, do you remember in geometry, when you had to prove something?
I'm not sure.
So when you do proofs, this is kind of like a proof problem.
Okay.
Everything in like in the GRE in essence is kind of like a proof. Like, those comparison ones. That's why I said, like, if there's a contradiction, then that must mean that you can't determine it. And then if they all agree, that must mean it's true. Because that's like a proof. That's a proof in essence.
Okay.
Like, every time you have a contradictory, then it's false, something like that. Okay. So I guess, not knowing like all of that kind of stuff, if you do method 1 for me here is like, why don't I just go with my gut, And method 2 is like, okay, now let me try to eliminate a few things and see what's left. That's how I categorize these ones. So method 1, I guess, if you look at this problem first, is you have this negative m over and 19 has to be an even and an integer though, right? An even and an integer.
Yeah.
Yeah. So that's an E here is even and an int is integer. So
okay.
So you need to know the definitions of those. So I guess integer, we kind of like touched a lot on integers, like what is an integer in terms of whatever. And it can be a positive or a negative, right?
Right.
And it has to be a whole number.
Right.
Okay. And then so the next thing here is, so that does it have to be even? Does it have to be odd in order? Because your constraint is this right hand side has to be what?
The right hand side has to be even and an integer.
Exactly. Okay. So that's a constraint. So that must mean the m has to be a multiple of what? Of 19.
Right.
Yeah. And then the other thing is, now you're thinking, is it an odd or is it an even to make this even? So this is just me testing different things. So what if we didn't use 19 because I wanted to just use some other arbitrary number, so 3. And then so for 3, I wanted to make it so that the numerator is odd.
Okay.
So when I do odd divided by odd, I get like an oddball, I guess, an odd guy. But then if I do like an even and an odd, I get like an even, right? So then my conclusion is this m has to be even.
Right. So I got that, but I also said that it was a negative number.
Yeah. So now, like, but the thing is, I think this one is only pick the one answer, right?
No, it says which of the following must be true. I guess I thought I could pick more than one, but.
What does it say? Oh, it does say that which of the following must be true, but
yeah.
Some of them, I know you could pick more than one. I don't know if you
right.
can with this one. Yeah.
Oh, okay.
What was the answer?
It was that it was an even integer.
Oh, so it doesn't have to be a negative?
It doesn't, which I thought it did.
Okay. So now
which is why I chose both of them.
Yeah. So you got that part, but then now let's try to look at the this one, like method 2. So method 2, what I'm trying to do here is for each one I'm trying to disprove that it even works. So for A, if it's saying m is a negative number, and if I find something like, okay, let's try to prove that this can work, meaning like the right hand side can be even and an integer. If m is a positive number, if I can prove m is a positive number, then m being a negative number is not good, right? It's going to be false. Like it doesn't work, because then it says it must be true. That's why it says like it must be true all the time, not sometimes, all the time.
So if m is a negative number, so
yeah, if it's saying m is a negative number, and then it's asking me, the question is like, which of the following must be true? So it has to be true. If you're saying m is a negative number, it must mean that it can't be a positive number, right?
Right.
But if I can prove that it can be, then it can't be A. It can't be m is a negative number, I think.
Okay.
Yeah. So that's what I did here. So like this first part, I just chose m being 38. That's a positive number.
Right.
And then when I did that, I got what, like a -2, right? And then that's still an even, and that's still an integer.
Yeah.
So
oh no, because m was positive.
Yeah.
And if m was negative, it would have made it positive.
Yeah, but then that still would, what I'm saying is like m doesn't have to be always negative.
Okay.
Yeah.
Oh, I see. Okay.
If it's sometimes true, that must mean it's not always true.
Gotcha. Okay, that makes sense.
Because it's saying must be true all the time. If you find a contradiction, then you can't choose that one. That's like the thought process there. Like if you find a contradiction, like for all of this, like for example, if it's a negative number, try to find the opposite of that. Like try to find a positive number, and it can't be that one then, because it must always be true.
Okay.
But then, like, let's try test the last one, because you said it could be the A and D, right?
Huh?
It can be A or E, right? The even number.
Right. So it can't be an odd number, you mean?
Yeah.
That?
Yeah. So for that one, like, let's see if that's always true. Like the even number.
So just by plugging in other even numbers?
Yeah. Like what you want to do for that one is prove if you can disprove it. If you can disprove it, then it must not be true all the time. So can you make an even and an integer right hand side if you if you can disprove an even number? That the main question here is, can you disprove that? If you can't disprove it, then that must mean it's always true.
And I guess the way to disprove that would be if there was a multiple of 19 that was an odd number.
Exactly, the opposite. Yeah. But can you do that one? Like if
no,
it's
I
an
don't
odd
think
number?
there is an odd number that's a multiple of 19, right?
Yeah, there isn't one. So that's why it's always true.
Okay. All right. I mean, it makes sense when we talk it through, but like then when I look at a new problem by myself, I have no idea what to do.
This one, honestly, like is one of the harder ones. It looks like a short problem.
Right.
But those are usually the scary ones, especially like these ones. But let me ask for this one, because like this one, if you get this one, like I'm pretty sure like all the other ones are not that bad, because doing like this method too, especially, does it make sense? Like when something must be true, or whatever I just said. Like if it's sometimes true, it's not always true.
Right.
And then the way you do that is you go one by one and disprove them by their opposite, or you disprove them by proving their opposite.
That makes sense.
Yeah.
Okay.
All right, almost done.
Yeah, I'm fried.
Okay, let's breeze through these ones like really fast. Do you remember this one?
Let's see.
Which one is this one? It's not on this page.
Oh, is it number 11? Yeah.
Yeah.
Okay.
Okay. So I guess I'll just tell you the assumptions I would make. So this one is this is the one actually. It tells you to apply. You can choose whatever many, however many, right? A, B, or
right.
C. Which is really tough. I don't like these ones, honestly, because
yeah,
if you miss one, you know.
Right. Exactly.
You're like all wrong. Anyways, so how I would go about with this one is like draw a picture and then like guess a few things.
Okay.
So I guess that my x-intercept is 2 and then y-intercept is 1. And then like the other one here is a and b and r and s. I would just guess these two values as like the x and y-intercept.
But it doesn't give you any points.
They don't give you any points, yeah.
So you're just guessing.
You're just gonna guess with these ones, because if you're not gonna guess, it's gonna make life tough with this one.
Right.
Yeah, because it's just like what it tells you here, like when does it ever apply, right? It's not saying like.
I mean, I got as far as drawing the negative line, but
okay.
I just didn't know how you were gonna. I don't know.
Okay, you drew the negative line, and then you got the slope then too, right? Kind of.
I don't know how you get the slope if you don't have any points.
But you know that this is a negative slope, right? At least you have a negative slope, and then this doesn't pass to the origin, right? I think
right.
That's what it said. So, two things: you don't know that. I mean, like you know that this doesn't pass to the origin. You know it's a negative slope by the slant down, and then let's look at one by one and see if it applies. That's how I would apply it. Like look at it one by one. Kind of similar to the other problem.
Okay.
The x-intercept of the line, whatever, it doesn't matter if it's k, is twice the y-intercept of this line. So that's an equation, right?
True. Okay. All right.
Oh, did I delete that in here?
So it would be y equals 2x. Is that the right? No.
It's the other way.
So the x-intercept is twice the what? I don't understand why it wouldn't be 2y if.
It is 2y, right?
I mean, I don't understand why it would be 2x because it says the x-intercept is twice the y-intercept.
Yeah, you know that key purple math website I sent you. It tells you that kind of the constructors, you know, like how these keywords come together. Every time you have an is, everything after that is just the equal sign. Is the equal sign.
Okay.
So x of line is equals twice the y, 2 times y. Yeah.
Oh, I see. Okay. So x equals 2y.
Yeah, I would like chop it like that. Like you don't have like x of line, so x on the left hand side is the equal sign, and then right hand side says twice the y. Don't read through it. Like you know what I mean? Like I know what you're saying. I would think about it that way too.
Yeah.
But like don't like maybe it could be on the moment you do that. Yeah, you can't continue.
Right.
Yeah. So x equals 2y is the first one. And then if it works for this, because I think this one, it just says like indicate all such statements. So if it applies, and if for our case, it does apply. So if you find a case that apply, it's okay. Like you can pick that one.
But I mean, I don't know how you can tell that it applies when you don't have any points.
Yeah, but then like Not similar to the one that we have. This is not like proving, like it could also not apply, is what I'm saying. But
like if your line was steeper, like
yeah,
if the x-intercept was 1 and the y-intercept was 4.
like you're saying, it doesn't always work. Yeah, you said it doesn't always work.
Yeah.
Yeah, but I think for this one, if it works one time, sometimes it's okay. It's not saying it's not saying must though, right? Indicate all such statements. It says. The other one was saying like must be true.
Oh, it's saying, oh yeah, if you had that information, you could conclude that it was negative. So if the x-intercept is twice the y-intercept, so if x was 2 and y was 1, it would be negative. Okay. Okay. And then the product of the x-intercept and the y-intercept is positive. So the product, so
That
x
one,
times y.
I think that one is always true. What do you think about that one? Because like you know how like the product of x and y, because
Well,
like it depends on your line, the direction of your line.
like if x was, you know, if the line was on the other side of the origin, the numbers would be negative.
Like this guy.
Right.
You
And
have this
you
guy.
have 2 negative numbers and they'd be positive.
Still positive, right?
Okay, got it. So
And
that's
two
true.
positive, two negative. Yeah, that one's always true. That one I know like is always true.
Okay. And then line K passes through the points A, B, and RS where, yeah, this one got me. I didn't know what they were talking about.
This one I thought wasn't true. Like I think it's not always true. That's why I don't think this is always true. But then like it applies in this case, because after you pick 2 points, you know, like after you pick 2 points, which I did, just plug in the number, the values for the variables, and then see if it's less than 0.
You just make up numbers?
Yeah, I mean in essence that if there's variables you're comparing them, you should just make them up and then see if it applies.
Okay.
I mean it's better than like not trying.
Right.
Never not, you know, like don't ever not try. Always try. And then like in all cases, like I forget if you get minus points. I think that was SAT. You get minus points. I forget already. It's been a while.
If what?
But like I don't, in the GRE you don't get minus points for guessing, right?
No, yeah, they only score the ones you get right.
Ah, I see. I remember. Yeah, I thought the SAT was the one that you get minus points. I forget for guessing, for wrong answers. If you get wrong answers, you get minus points. I know, it's a weird one. Okay, let's continue with this one. Okay. So this is a comparison now. I think this is one part of the comparison. I didn't do the other part.
So let me see if I can find that one.
Okay.
So
this is the one that was.
Yeah. Okay.
Okay. All right. So I think I did 1, 2, 4, and then I think we're good. So do you know how, like, after we've I kind of just didn't write like my assumptions, but do you remember doing like, you know, the steps for comparison?
I mean, I got really confused. I started writing an equation, but it.
Okay.
I got.
What was your equation?
I was trying to do like, so 1 times. So if quantity A is the dollar value of 1 peso, it's 1 times 0.93, right?
Yeah, there's a logical way of thinking about this, and then there's like the quantitative way.
Okay.
So like the logical way is, you know how like convert, you know, like when you convert like dollar amounts to other currency, like in a way you could just guess which one's higher, because you know how like if you have like currency that's like less than the dollar, right? Less than the dollar. It's usually because it's a part of the dollar, so that must mean it's higher, right? That must mean it's higher.
Right.
And if the $1 is greater, you get multiple of it. That must mean it's lower. Okay. That's the logical way of thinking about this.
Oh, I see. So so quantity A is greater.
Yeah, but then forget that and just like do the math. You just pretty much divide them, the numbers. It doesn't matter the units here. Just divide the numbers.
I was trying to multiply.
Divide it.
Okay.
You have to divide it. Yeah. And then like once you divide it, it's easier to see that A is still greater.
Okay. This one was frustrating because I I could tell it was easy and I still couldn't get it.
Yeah. I mean, if you have like, it doesn't give you an equation. It's more like, I think there's always that question is, why are they asking you this question?
Right.
And I think it's just, what are they testing you is, I mean, yeah, one year, do you know how to do or interpret currency exchanges? And the other is like, I mean, like really, if you have something like this currency, I would just attack it as divide the numbers.
Okay.
Just divide it without even thinking about it. Like, okay, whatever, just divide it. Okay, which one's higher? That's it.
Okay.
And next one. Okay. What about this one?
All right, so K is a digit in the decimal. And it's less than 1.33. So
yeah, this is like another digit
right?
problem.
K would have to be 1 or 2.
Yeah. So what would so like this? I guess for this one it's good because at least B is a constant, so you only have to worry about A. Okay.
But did you get that too? That K could be 1 or 2 or 0? Okay.
Yeah. Did you get this one? I didn't know what your answer was for this one.
No, I gave up on all these. Like I didn't even attempt them because I was like, I hate these.
Yeah. Like I said, if you apply, oh yeah, that's also the other thing. You know how like you get selective in your questions.
Right.
No, I got to that point when I'm answering these, it's like some of them are frustrating.
Right, and I just was like, I don't know how to answer this style of question.
And then what I mean by I get very selective in what I'm gonna study.
Right.
And then like, because I don't want to frustrate myself. Who does?
Right.
Who does? But then in my mind, I was like, after a while, I was like, you know what? I want to study now what I don't want, and then and eventually, especially like a lot of the things I didn't like, not this part, because I guess I'm good at the math part, but like, you know how like in the verbal, you know how like the vocabulary, there's a lot of those that you have to remember. I forget the ones where you have to like compare a few things. Well, right. It was a while, but then like you have to like stack up. You know, it's not like you're gonna use those words like every day.
Yeah, yeah, that is the hard part.
Yeah, but that's what I mean. Like, if there's things that you don't like to do, you should focus your mind on those more for the test.
Right.
Yeah. Okay. So yeah, for this one, yeah. So that is right. You do get multiple things. So that must mean that it's D, right?
D, that you can't get the, so that is number 2. Yep, that's right.
Okay. All right, for this one isn't bad, but it's a geometry one.
Right. Like I said, I haven't tried any of them, so this is a good place for me to start.
Okay. So I guess I'll let you read it first. So it says like AB is a diameter, right?
Right. So AB is the diameter of the circle above. So that means the line, any of those lines. So A and B.
Yeah.
Oh, I see. So A. Okay. So the length of AB, or the average of the lengths of AC and AD.
Okay, yeah. If you draw a picture, it's easy for this one.
I mean, there's no way to know like what those lengths are, really, right?
There isn't, but here. Try to let me see if I can. So you see my picture?
Yeah.
Okay, so very arbitrary, but there are things that you can assume, like knowing what they gave you. So you know how AB is the diameter, right? So by definition, what does that mean? That's a diameter is the what? Oh shoot. The diameter is the longest chord, right?
I guess I did not know that.
Yeah, like if you had like anything, like it could be anything that connects these, from point to point. These are chords.
Oh, I guess that makes sense. Okay.
And the diameter is always the longest guy.
So
that gives you that. It's always the longest one, like from end to end. So That's one thing that you can get from that. And then now, yeah, let's look at like quantity A and B.
So the length of AB.
Yeah. So length of AB is just the diameter.
Right. The average of the length. Okay.
So now let's look at this one. So because like it's always like if this then that. If AB is the longest guy, right? Like from end to end, then AC and AC compared to AB is going to be less than AB, right?
Right.
And then AD is also going to be less than AB. You just know that. It's like
right.
That's like if this and that has to happen. And then now, but then you're not even comparing them. You're not even comparing that one. You're adding them, right? And
right.
then taking the half of it.
Uh-huh.
So now this is just simplified form, right? Like, see, this is me just saying putting that into an equation. What I just said.
Right. So each of those are less than AB.
Yeah, and then so this whole part right here, if you want to think about it like a step by step, is just what are your assumptions? These are assumptions, and then now there's no equation, and it's in a way in a way you made up your equation here, right? And this is a simplified form. You always want to think about like simplify then plug in, right? So after you simplified it, it's the most simplified form. Now you want to plug in the extreme values.
Okay.
You want to plug in the extreme values. So what are your extreme values here? Like if I were like, well, it doesn't give it to you, right? There's nothing here.
Right. So you have to make them up.
Yeah, but I would make up like really easy numbers. I would start with like 10, like as like the largest value. So that's what I did here, 10. And then the extreme values would be like 9 is the highest, and then 3, these are the lower ends.
Right.
And then let's see if I get a contradiction or not.
Right. And so it looks like, yeah.
And I don't, and I never get it. And so that's good. I could probably test a different number and see if it's always greater.
Okay.
And that's how I would attack those ones. There's no number, but there's things you can assume.
Yeah.
And then always apply to simplify and then plug in.
Okay. I mean, it's definitely helpful going through specific questions.
Yeah, but you could see that strategy always applying though. In essence, like if you were to see another one like this, like kind of. I mean, like the more you do this, you're probably gonna see another one. The one thing about like these practice problems, like there are similar ones, but they're all mixed up.
Yeah.
Like, you have to really like know how they're framed. It's like, okay, later on I'll see it and then I'll know what it is.
So I guess the strategy is like going through these sample problems and then just looking at the explanation.
Exactly, yeah. And then like the best way is by now I'm hoping like you've kind of created the framework in your mind. And then like just doing more of them. Like don't attack it the way you did before. Attack them in like a strategic way.
Right.
And then kind of emulate that every time.
Like, then I just, for example, I look down at the next one and I have no idea what to do.
Yeah, but try to like break it down. That's the best thing. Like break it to what you know, and then maybe think about it for 30 seconds or a minute. It's like, what can I do? And just like go with it. Go with that gut feeling. What would you do? If it doesn't happen after 1 minute, then move on. Like honestly, it's not worth your time.
Right.
Yeah.
What if they're all like that for me?
For these ones, yeah. Yeah, I guess in reality, you have to do more of them. Like you just have to do a lot more.
Okay. I guess
like
that's the strategy now is just like looking at the explanation and doing it that way.
Yeah. It's kind of like just like acquire. I mean, yeah. Math is hardly acquired. You have to, you have to like really, like knowing the concept. Just know the concept. After you know the concept, then just strategize. Like, most of the concept. It's just the framework of the problem. that kind of intimidates a lot.
Right.
But after a while, though, like I said, you're gonna acquire that framework. After you acquire that framework of, because these GRE like logical things they're pretty intense in essence, and you'll never see them like applied, honestly. Like someone makes up these problems, like especially this one. Why would you want to compare the length of AB? You know, like, honestly like it's just at this point it's just that roadblock. But I'm pretty sure you're gonna get through it.
I am not, but anyway, thank you for trying to help.
Yeah, no worries. And then let's just cover this one, and then I'll send you my stuff, and then I'll work on like the rest of it and send that to you.
Okay, thank you.
Yep. And then so let's see. So this one's not that bad, right? If you look at it, it's another one of those equation ones.
Yeah. I just didn't know how to get started.
Okay. So it gives you S times T equals square root of 10, right?
Uh-huh.
That's like the, prompt. It gives that to you. And then the quantities. So what the quantity is for A, it tells you S squared. Mm-hmm. And then B, it tells you as 10 over 10 squared, 10 over T squared. Mm-hmm. And then so what you usually do with these is like you want to plug something in somewhere. You want to plug something in somewhere. You could either take the S route or T route. It doesn't matter.
Right.
So I took the S route. I selected the S. And then you're going to see, like, once you do that, you're going to see that A becomes the same thing.
So S equals the square root of 10 over T.
Yeah.
So I'm confused how this next step, you just went back and squared everything again?
Oh, yeah. Okay. Let me see. This step?
Yeah. So you went from S equals square root of 10 over T and like squared it again.
Oh, yeah. Let me just say, so this equation is from the prompt. So the prompt gives us like a relationship.
Okay,
right?
Okay.
Yeah. So what I wanted to do here was take the prompt question and then try to find S squared. That's what I wanted to do.
Okay.
Yeah. And then when I did that, I plugged in S in the S squared. I got 10 over T squared.
I don't.
Yeah, it's like you're given two things that can equal each other. That's just like, and the question you want to ask is where can I plug in what?
Yeah, I don't see what you did. Like I know that this S equals, I now know that the S that equals the square root of 10 over T is simplifying the given that they give you.
Yeah.
And then like you did S squared equals, and you just simplified that.
You could do this. Yeah, you could do it like two ways. You could do it like that. You could either have this, which I did, and then you could also do this. I did it this way. You could also do this though. Right?
Right.
So what if we did it that way? The thing is, I guess what I'm saying is you don't have to work with what they're giving you. You can throw it out the window and just distort it.
Right.
And create your own. This is what it is. Like you're gonna have to create your own equation and manipulate it if it gives it to you.
I guess, yeah.
Yeah, like this one will work if you manipulate. The one thing is you have to manipulate the given equation.
Right. So you solved each of them for S and T.
Yeah.
And then so then if you plug T into A is the square root of 10 over I don't know.
Are you doing this one?
Like,
so S squared, right? I'm gonna scroll over. So S squared, right?
Mm-hmm.
So I'm gonna take what I manipulated from the prompt, and I'm just gonna plug in what S is. I'm gonna plug in what S is, and then I'm gonna square it because that's what A is. A is A squared. or A is S squared.
Right.
So once you do that, right, it's 10, isn't it?
Right.
The numerators, and then the denominator is T squared, right?
So they're equal.
Yeah, that's what I meant. They're equal.
Okay, that
At
makes
the end
sense.
of the day, they're equal, yeah. You
All
could
right.
have done it. You could have done it the more complicated way. This is a complicated way. If you made it T
So you
instead of S.
manipulate the given.
Yep.
Okay.
You could do that. You could do whatever you need to do to make the problem easy. That's the both good and bad, you know.
Right.
I mean, like, you can go in so many different ways, like, but why? And no one's gonna tell you how.
Exactly.
But I think that's a good thing sometimes, because it's like it prepares your mind to like be creative in a sense.
Yes.
Yeah. But yeah, that's this one.
Okay.
This one's a pretty short one. Oh yeah. Oh shoot! I totally forgot. Before we end this one, like, I wanted to cover with you the Venn diagram one. Do you remember that one?
Yeah.
Yeah, I was supposed to cover this one. I don't know why I didn't, because this is a hard one. Okay. Do you remember looking at this problem?
I do.
Okay. So the Venn diagram, because there's a lot of these. Like, I'm just gonna say that there's a lot of the Venn diagram ones.
Okay.
So when you look at a Venn diagram problem, you could either draw the Venn diagram, you know, you could either do this, or you could even make it like. Do you remember, or do you ever, like, have you seen something like this where it's like a quartile? But you've seen this. You've seen this one though, right?
Yes.
Okay. This other method, it's kind of confusing, and then the third method is just using the equation. I would just use the equation for this type of problem.
Okay.
And for the most part, I've seen the ones that it could be three things being, like, you know, you could have, because this one is only two things, right? It's like
the number of students, right?
Yeah, 142 algebra, and I think 121 chemistry, I think.
Right.
Yeah, but then there's ones where you could have like algebra, chemistry, mathematics, you know, like whatever, three things. And then I'm hoping there's not a fourth one.
Right.
But for the most part, they're all kind of pretty much the same thing. Like when you're applying this equation, when you're seeing this one, you have to apply this equation.
What is that equation?
The book doesn't talk about this one, this equation.
I don't think so.
What does it tell you how to solve Venn diagrams, or how's it wanting you to solve those?
Well, I can look at the explanation for that.
Okay. Because as far as I know, there's like three different ways. the Venn diagram. Okay.
So it says to do the Venn diagram.
Okay, that's method one.
But it doesn't. Yeah, it doesn't say anything else about that equation.
Okay, so I guess this is a new equation then.
Right.
Okay.
Yeah.
Okay, let's just go over it then. Like, I'll explain that part. So, looking at what we have, like this equation, I'll explain it first. So when you have like Venn diagram problems, you're always going to be given a total, right? Total number of students, total number of, you know, people, whatever, and then it'll categorize like more than one thing. It has to, or else you're not going to be doing a Venn diagram. So it's going to be like X or Y are those two things.
So X plus Y.
Yeah, are those two things that tell. Yeah, minus B.
Which is what?
B is both X and Y. Like, I'll tell you both algebra and chemistry. That's B.
And then what's N?
Neither X or Y.
Okay.
Yeah. And then the total is everyone. It's pretty much the Venn diagram in essence.
So,
like,
but this one doesn't say. How do you? I don't know.
This is both, right? Yeah, that's both. It's pretty much the Venn diagram in essence.
Okay.
Because this x is everything here, and y is everything. So that's why you're minusing both, right?
Right.
Because then it's twice, and then plus neither. Because there's two categories, but then there's other people here.
And 121.
Yeah.
But yeah, I don't know.
Okay, but does this equation make sense?
Yes. So would the neither be? Gosh, I just don't know how you figure out the b in the end.
Okay, so a lot of that's like the bulk of it. They'll always give you a total. The scenarios for this problem, they're always going to give you an x. They're always going to give you a y, right?
Right.
Like they always assume that. They always give it to you 99% of the time.
So we have the total and the x and the y.
Yeah, and then the other 99% of the time, they always give you one of these guys. They always give you both or the n. But then 1% of that time, they're not going to give you either one.
And that's what they're doing here, right?
Yeah, and that's why they're screwing with you. So this is the time. This is a level 3 one. This is that problem, the level 3. They call this the Venn diagram minimum maximum variation. So it's like minimum maximum variation. You'll see why. So if you get this one, all the other problems are easy. because you did the hardest part, the hardest one. So all the other ones fall beneath it. So what you do here, so knowing that equation, now you can tell what this means, right? What these variables mean, right?
Right.
Okay. So now let's look at this. So b and n are not given. Okay, and also one thing to note here is b is always negative, right? B is always negative.
Right.
N is always positive.
Okay.
That's why it's going to become more clear when I say minimum maximum, because it's negative both, positive neither. And now what are you trying to find?
You're trying to find b. Yeah,
the maximum, I think. Didn't it say maximum something?
Oh yeah, maximum b.
Yeah, so that maximum, it becomes a key word, because then it tells us what direction or which to maximize or which to minimize.
Okay.
Yeah, so for this one, let's assume obviously which to maximize. So we're going to maximize the b. So the first thing I would do is the logical statement. Like, after thinking about the problem, you can make these up in your head, where if you maximize the b, right? This is maximizing the negative, right? Then you must have, in order to maximize the negative, you need to add, you also maximize the n, right? To have the greatest effect.
Okay.
Right? Like, so you have the biggest difference. You have to maximize the positive.
Okay.
So that's the one thing to remember about that one. And then if it's asking about maximum b or maximum n, you have to take the total and you minus the maximum of either one, x or y. That's just how I would think about it. In essence, the maximum of this is 142, right?
Yes.
Yeah, because then it gives you the maximum n.
Okay.
Okay, and then when you minimize the n, then you take the minimum of those two.
Which is 121.
Yeah. So you just have to remember those two, 1 and 2.
So if you're finding the maximum b, I don't know.
Yeah, to get the maximum b, you need to maximize the n.
You add them together? You add x and y together to get the maximum b?
Add what together?
X and y?
And you don't add x and y. You're already adding it in the equation.
Okay.
But you have to find what it is. So, but then since you're not given either b or n, you have to assume something for n. This is number 2 here. You have to assume something for n. So assuming, because n can go 2 ways. And like, you know, just looking at these, looking at these, and max can be like the t, right? Minus, and then what is maximum x or y in our case? Isn't it x?
I'm lost. I don't know.
Here, let me put the numbers in here. So you know how you have n, and then so you have 236, right? This is, I told you this is a hard one. 236, right, is your t.
Uh-huh.
And then you minus 142.
Why?
Because it's the maximum number to get the maximum n. Like, because you want the maximum like b. So that's like
I'm sorry.
have to,
It doesn't make any sense. I'm sorry.
I know. It's those special rules that you have to like just. Okay, for example, you have 236 people, right?
Mm-hmm.
And then 142 is like the algebra, right? And then 121 is the chemistry.
Right.
Okay, so when you're minusing the algebra, what are you doing to the total? What does that give you? The neither, right? They're not doing algebra or the chemistry. Right?
That doesn't make sense to me.
Okay, so you know there's 236 people, right?
Right.
And in like, let's just forget about what it tells you, but it tells you that there's algebra here and then chemistry.
Right.
And this is like the universe here. 236 is all, and then we're categorizing it as algebra and chemistry, and then we're saying here there's like 142 people doing algebra, right?
Yeah.
But not, and then, but not what? Not chemistry. If you're doing algebra, you're not doing chemistry.
But that's not what it says.
No, but then that's what I'm saying. Like, it doesn't give that to you. So
right.
you have two choices for neither.
Because those 142 people could also be taking chemistry.
Yeah, for both, right? It could also be both. It could also be both, right?
Right.
Like, if it's it could be that, or it could be chemistry, which is both. But those aren't given to you, so that's why you have to make some of these assumptions. You have to make some of these assumptions to make sense of like a conclusion, or somewhat of a conclusion. Because if what was your answer for this one?
27.
Yeah, no, I saw that one. It's like that's what everyone always assumes for this problem. And how did you get that one?
Yeah, just by subtracting. What did I do?
Yeah, I want to know how you got that one.
If I can remember. I don't remember how I got it.
Maximum neither. A maximum, was it both? Yeah, maximum both.
I think I just like added.
Oh, I think I know what you did. I think I know it. So wasn't it like this? You did like you did like 142, right? Plus 121, obviously. And then what B? You solved for B, right?
I mean, I didn't know what B. I didn't even know.
Because like if you solve for B, I think it's 27, isn't it?
I don't know.
Yeah, let me just look. Let me look at that one. 236, 142, 142 plus 121 plus 27. Oh, it's not actually. No, that's not the right one.
Plus 121.
How'd you get 27?
Oh, and then subtracted the total from it. So that's 236. So 236 minus, I'm sorry, 263 is 142 plus 121. And then I subtracted 236, which is the total number, which made sense to me that would be the double.
Okay. But that's not the answer though, right?
No.
What's the answer?
121, just like you got.
Okay. Now that I'm trying to think about this, it's because like let's try to figure out, because like it doesn't really give you like neither. The one thing here, it doesn't give you a neither, right? It doesn't get to, which sucks. So that's why you have to assume. But two things can happen with the neither one, right? Like this can either be, I think, 94 and then 115, I think.
Yeah, I'm just never gonna get those numbers. This doesn't make sense to me. I'm not gonna get it.
Yeah, if you were to see this, because I think there's a very, like, if you were to see these numbers though, maybe you could just guess on this problem.
I mean, and it's just, you have to write it in. So like, I don't have a good strategy. It's fine. I'm just not gonna, I can't do
Attempt
it.
this one. Okay, it's just 1 out of like 20.
Yeah, but I mean, I can only do about 3 out of 20. So
Nah, I think now you could probably do like at least like 12 at least. I'm pretty sure more than half. Try it again. Try them again. Like I'm pretty sure, because like for this problem, like I said, if you the more, like when I studied for it, it was actually like more effort than taking the exam. I'm pretty sure once you take the exam, it's like, oh man, that wasn't that bad.
well, I don't know.
Yeah, because one of them is actually like a test one. Like they're gonna give you like a test one that doesn't count, and then I think they pick. I don't know if that's the verbal or the math, but a section is like it doesn't count against you.
Right.
All right.
All right. Well, thanks for trying to help.
Yeah, but yeah, like I said, so I'll send this to you, and then I'll the ones that you gave me, I'm gonna send you the solutions for those as well.
Okay.
And yeah, let me know if there's anything there that that you want answered.
All right. I appreciate it.
Cool. Thank you.
Thanks. Bye.